So I know we've all exhausted our time after the launch, so I'll just be very quick here. So I'll be presenting about machine learning application that we've developed, so a software-related application. So the initial idea was to see how we can be able to create a system that will be able to predict genes that are associated to a particular disease and so on. So in our study, we follow through the path of precision medicine. So if you don't know much about precision medicine, it's about having a particular patient's disease and record, understanding the causation of those diseases, and also tailor particular treatment that will be able to be unique to a particular patient in terms of diagnosis and also providing treatment regimen. So what we've done in this research is to be able to look at a particular data set. We have about 27 neurological phenotype diseases. So out of those 27, we selected just one of these, which is Parkinson's disease. So our idea was to be able to create a classification system that will be able to predict, at least give us a very good, accurate measure of our prediction, because what we are doing is to be able to predict genes that are mutated in a particular disease, like Parkinson. That's to allow us to be able to provide a good diagnosis of those the disease itself, so as to allow us to provide treatment regimen for that particular patient. So when we did the experiment, we discovered that having used these algorithms, machine learning algorithms, and also some ensemble algorithm as well, we discovered that random forests and the likes of extreme gradient bursts had performed in terms of the accurate prediction classification in our experiment as compared to others. So the idea of our research is to have these huge algorithms and to test these algorithms in terms of predicting whether our model is classifying or associating genes that mutated to a particular disease largely. So this very study is from a very large multimodal study. So we have images, we have text, we have also sound data. But for this very experiment today, what I'm presenting is just a test-based experiment. So what we did was to be able to convert the test data into induced probability binary representation. And so that's the only way we can be able to use these machine learning algorithms to get this result that you've seen. So for us to evaluate the system itself, we did use some of these SME and also MEE measures. So if you can look at the result here, you discover that even though we have a benchmark algorithm, which is neural network, we discover that extreme gradient burst and also the likes of linear regression had performed the neural network model. And so for you look at the second to the last column of the errors, we discover that the lower the errors, the better the prediction in terms of whether our model is predicting that gene ABC is associated to Parkinson's disease and so on. Okay, so in summary, the aim of our research largely is to be able to translate a machine learning method or algorithm into a software application. So that is the aim, so that we'll have clinicians, patients have that interaction with the system and type in a particular gene and have a prediction that this gene ABC is associated to Parkinson or is associated to early onset dystonia and so on, largely. Thank you.